Hi S3, it's Mr. Bill here, and I'm just going to be talking to you through the next stage in the course, which is projectiles. Right, so let's get on with it. Our heading is projectiles. Now, you'll be used to the word projectiles because you throw a projectile and you've probably thrown something off a cliff or off some sort of height and got maybe some sort of ball or something like that. So let's take that example and have like some sort of cliff there. And a ball. Now, when you throw this ball, you'll be aware that it has some sort of curve, like that. And that curve comes from two sets of motions. A horizontal motion and a vertical motion. So, we have a horizontal motion and we have a vertical motion. And both of these motions come together to produce that curve. And they actually both have two constants. So one constant here and one constant here. When you throw something, and in National 5 Physics we're going to neglect air resistance or any sort of friction, it actually has a constant velocity. Its velocity never changes when you throw it. And in the vertical, it has a constant acceleration. Now that constant acceleration is due to gravity. Of course it is. Because when you throw something, it will have the effect of gravity on it, or the force of gravity on it. And that will be pulling it downwards. Gravity doesn't change, therefore you have a constant acceleration, but its speed does change as it falls in the vertical way. But in the horizontal, it stays the same. Right, I'm going to show you a wee video of my dog Nova when we're at Lynn Park, and she just loves to jump into the water, but it makes for a really good projectile. So I'm going to show you this video now. So that's Nova, and as you can see, she loves the water, loves jumping into the water. But as she jumps, she's moving with a constant horizontal motion. But I mean, she doesn't get very high, but she's being pulled down by the gravity of the earth into the river. So you can see that there's two things happening here: horizontal motion and a vertical motion. Right, how would we then begin to start actually answering this in terms of equations? So, when you consider a question, you have to see, is it asking for the horizontal or is it asking for the vertical? If it's asking you for the horizontal, now remember the horizontal is always constant velocity, you actually just use an equation that you used at the very beginning of S3, which is, if you can look at all these letters, you'll see that it is speed equals distance divided by time. So when you answer this question, you can just do what is the speed, what is the distance, what's the time, and wherever you don't have, you can figure out using speed equals distance divided by time, or velocity equals distance divided by time. So that is an equation you're used to. So horizontal should be quite an easy and straightforward question. However, for the vertical, we have this. And the reason why I'm doing that is because it makes it easier to understand what you need to figure out when you have all the letters accounted for. So you've got, for example, in this one, you're going to have U, which is initial speed, V, which is final speed, A, which is acceleration, and T, which is time. Now this should be ringing bells to you. It was in the format of A equals V minus U over T. And you'll be used to that from near the beginning of S3. Now, that there is not the format we normally like to use. And actually one of the nicest formats we can use for this question is V equals U plus AT. Now that is exactly the same equation as that, but just rearranged. So you can do the maths, you can do the algebra, but it does get you V equals U plus AT. And in every single National 5 equation, this will make it really easy for you, the initial speed will always be 0 because you're starting off at some sort of cliff, and your physical speed is going to be 0 there. So 0 meters per second. You won't know your final speed. It will give you a time, but your acceleration will always be 9.8 meters per second squared. Just as it is, always 9.8 meters per second squared. So if you have those two, you can actually figure out this really easily. So V equals U plus AT is something to remember. That's not in your equation booklet, that one is, but this will really help you when it comes to projectile questions. Now, once you've figured out if it's horizontal and you use that one, or it's vertical and you use that one, sometimes it asks you for d vertical, or the distance of the vertical drop of the cliff, or of the height of the wall or something. And to do that, you actually need to draw a VT graph, because you remember under a velocity time graph, you get the distance or displacement. So let's just draw what that would look like to remind you. Then you use D equals A dot U dot G area under graph. Okay, so if it's asking you to find the vertical distance or the vertical drop, use your VT graph. Create a little VT graph and then use distance equals area under that graph. And that should be everything you need to know with regards to projectiles. Now that's quite difficult. So we're going to actually do an example in a day or so's time, but you're going to try and see if you can do it first, and then I'll do it, and then we'll get on to some questions near the end of the week. Hope that helps, S3. Any questions, just comment and we can help out, maybe even with another video, or hopefully just with typing underneath. Thanks, S3.